This is Dr. Lee Osler, part of the Asea 5. This is our Friday night webcast on December 11. We're getting close to Christmas, and we're so glad that everybody is joining us from around the planet, literally from Malaysia, Singapore, Montana, and so forth. So we're glad you're here. We've got an exciting show for us tonight. We've got Dr. Ralph Stevens in the house with the Asea 5. And he's going to share with us some of his expertise with regards to cell biology, because that's what he is a cellular biologist. And that's something that is so exciting, especially when it comes to what we're doing with redox signaling molecules, because that's all about cell biology. So we have with us Jim and Ann Glenn from San Antonio. You can wave there. My name again is Lee Osler. I'm in the state of Washington. Maureen Hayes, Dr. Hayes is in Galveston. Give us a nice smile. And of course, Dr. Ralph Stevens. Before we turn the time to him, we just want to make a disclaimer right up front that the things that we talk about tonight with regards to redox signaling molecules and Asea are not a cure, or this is not about diagnosis, and we're not making medical claims. This is technically a nutritional supplement. And through the course of our discussion this evening, hopefully you'll come to understand the inner workings of what this is and how it works at a much deeper level. With that, I would like to introduce our special guest tonight. We've had him on before, and so we're going to pick his brain a little bit more tonight. Dr. Ralph Stevens received his PhD from the University of Tennessee in 1970. He spent over 10 additional years in research and training in the fields of radiation biology, molecular biology, and cell biology at such institutions as the University of Toronto, Fels Research Institute, the Wistar Institute, the Mayo Clinic, the Ohio State University, where he eventually joined the faculty in the Department of Radiology and Pathology. Dr. Stevens ran the cell culture laboratory at Ohio State University for over 20 years. He investigated cell division for over 30 years and concentrated his own research on the difference between human aging and cancer cells. He published numerous papers and book chapters before retiring in 2001. Ralph, it is such a pleasure to have you with us. I think you're the consummate expert in this arena because of your background and your understanding of how these electrons move around inside our cells. Give us, if you could, as you introduce yourself, what I might have missed out you want us to know about, but tell us what brought you to the game? What was it that attracted to you, and especially with your professional mindset? What was it that intrigued you?
Yeah, I want to say something real quickly because you kind of messed up on the intro. And Ralph, I know Ralph is
I'll
going.
leave and come back, and you can do it again.
We're not kicking you out, Ralph.
Oh.
It is the.
I was going to give him another
State
chance.
University. The Ohio State University. I just want to get that clarified, right? Ralph, thank you. I am from Ohio, so I just wanted to make sure that I've been in Texas a long time, but I'll always be a Buckeye. So anyway, I'm sorry. Go ahead, Ralph.
Well, I've got another disclaimer, actually. I am a cell biologist, and I don't know if you realize this or not, but a cell biologist is someone who knows a little bit about a lot of things, but don't know a lot of things about anything. So I'm a cell biologist, all right, and I'm kind of proud of all of that because it gives me a breadth instead of a depth, okay? So I don't think I'll be going into a lot of weeds tonight. But right. You wanted to know how I got into it. I got into it because a friend of mine, very close friend of mine, she was my estate planner. Nobody's ever heard of her. Her name is Pepper Black. But she talked me into drinking this stuff 7 years ago. I was on my way to Jamaica with my wife and dropped by her office because I had to sign some papers for my estate. And she said, "You got to try this stuff." Okay. And I said, "Oh, okay, well, she's really going to help you." And I go, "Okay, fine." I said, "Can it hurt me?" "Oh, no, can't hurt you." Well, now I did trust her, okay, because she had been my estate planner for many years, all right, and I totally trusted this young lady. But just between you and me, I knew it wouldn't work. I'm a scientist. Give me a break, right? It's going to help me. Yeah, this is going to help me. Yeah, sure, fine. But it can't hurt me. That part I believed. All right. So I went on to Jamaica. Yeah, I paid for the stuff. So yeah, I drank it, right? So about a month and a half later or something like that. And I apologize for this, Jim. I have checked this out over and over again, and I do not know why this cuts out on my video. But I was playing ping pong up at the senior center in Crossville, Tennessee. We could play ping pong. We knew how to play. Some of us were ranked. One of them was ranked 7th in the U.S., and the others go to the Olympics every year, Tennessee Olympics, and medaled. So we knew how to play the game. But a friend of mine, former Navy flight surgeon, said, you're playing with more energy and quickness than I've ever seen. This is an MD, and we've been playing together for 5 years. And I go like, So I kind of stepped back, and he was right. You know, I was still playing. I wasn't the least bit. My knees weren't shaking. I wasn't winded or anything. I didn't feel like I had to take a break. So he's right. There was something different. I didn't know what it was.
How young were you then, Ralph?
Pardon me?
How young were you then?
That was 7 years ago.
Okay. Well, so how old are you, Ralph?
I will be 80 in a month and a half.
You don't look it. Amazing.
That's awesome.
I knew I had to get the age out of you somehow.
Yeah, yeah. I'll be, and actually, I'm looking quite forward to that, to be perfectly honest.
Yeah,
You look fabulous.
yeah.
But
Playing ping pong, goodness.
you hear people that have their aha moments. Well, my aha moment was from someone else. I didn't have it. He had it. Okay. But then I realized there was something different. He said something really peculiar. Then he looked at me and he says, "Are you on anything?" and then I really stepped back and I said, "Well, yeah, fish oil, multivitamins, and Asea." He said, "What's Asea?" I said, "I don't know." But I'm going to find out. All right. So I went home, got out of my lazy chair, put down my bowl of popcorn, my remote control, looked up, it says redox signaling molecules. What? So I went to PubMed.gov and I said, what is going on? And that's why I'm here tonight. I found out a lot about what's going on.
Okay, so
For over 50 years, and I had all of these questions, and all of a sudden, here was some answers that I've been looking for all those years ago.
so in the beginning, Ralph, you did not look into that at all? You being
Oh, absolutely not. I knew it wouldn't work. Are you kidding? I'm a scientist. Give me a break.
now I do know
Saltwater
Pepper,
from Salt Lake City.
but I do know
Give me a
Pepper,
break.
and I know she can be a little bit on the persuasive side. We all love Pepper Black.
Oh yeah. Oh yeah. You got to try this stuff. Yeah. Okay.
Just
Fine.
really trusted her though, Ralph. I mean, you know, if you look at the back of the bottle, it says distilled water and salt. So
It's salt water. That's right.
yeah, salt water.
I knew she really, really believed in it because the next morning my wife and I were about to get on the airplane, and she showed up with 2 bottles of Asea. Okay, you need to drink this in Jamaica. So I knew then that she really believed in the stuff.
Wow.
All right, really, really believed in the stuff. Of course, she didn't give them to me. She just loaned them to me, but that's beside the point. She was a good business person, right?
Great.
And I can always trust that. That's very important to me. All right. And I do appreciate that too. But that's the way it all started. And then I started looking into it and I go like, what the heck is going on?
Do you see Pepper's writing in the chat? It was 4 a.m. She showed up at 4 a.m.
Wow. You had an early flight.
Beyond persuasive.
Yeah, we love
Okay.
Pepper.
Yeah, we had this issue the last time. He has to keep flipping it back on.
All right. I have another
You know-
camera.
Yeah, I was going to say, Ralph, the last time you called in on your phone.
I had this. There
you go.
I had this Zoom on today for 2 hours straight, and it never canceled on me. All right, this is a different camera. I bought another. Oh, I like that. That's really good. that may not be that's probably my best face, my best side. Okay. Anyway, I'm a little washed out here. You're going to have to just put up with that. But I started finding out what these molecules were, and I really started appreciating them. My professional experience, that's a personal experience that I had. And it caused me to backtrack then and start putting that in place with some of my professional experience. Professionally, I got interested in cell division. A professor of mine took me to Beaufort, North Carolina, at Duke University Marine Laboratories, and we were collecting sea urchins. And we zapped them with a little electricity, and we got eggs out of some and sperm out of some. And I took a dilute solution of sperm and mixed it in with the eggs, and I looked under the microscope. This is where I've been for 40 years, is looking under a microscope, looking at those eggs. And as soon as the sperm touched that egg, it changed colors. And I continued to watch, and then I saw one cell go into two cells. And when I saw that happen, that is what sealed what I did for the next 40 years of research. How did it do that? How did it go from one cell to two cells? And that's what I got excited about. But wait a minute. Now I know more. So let's back up. Remember when I said the sperm touched the egg, it changed colors? How did that happen? Because if it changed colors, you know the chemistry changed. And we knew that one of the reasons that the egg protected itself is it didn't want two sperms to fertilize the same egg, right? But as I kept looking, and new science is coming out now, that what is on the inside of that egg's membrane is hydrogen peroxide. And when that sperm touched the egg, the hydrogen peroxide was activated all around the inside of that egg, changed the chemistry so that another sperm could not fertilize the same egg. So what I'm talking about now, folks, is detect and protect. You've heard those two words before? Hydrogen peroxide is a redox signaling molecules. It detected when the sperm touched the egg, and it protected the egg from being fertilized by another sperm. So that's two important points right there that I had completely overlooked. All right. And now they become even more important to me. That's the way it all started. And that's what I've learned since then. Can I go now?
So when you started all this, Ralph, you what I think I heard you say is that for 40 years you were doing all this conventional research, conventional science understanding, and then when redox signaling finally came across, I'll say, in your vocabulary, suddenly when that became the concept, all of that, or much of what you had already known for 3 or 4 decades, came into greater clarity for you. Is that as a mechanism?
Yes, a lot of the questions that I had started to make sense. I was studying cell division, right? So I grew in cells at the Ohio State University. I grew only human cells. I grew normal cells. I grew cancer cells, lots of different types of normals, lots of different types of cancers. Some of the experiments I did is I would take normal cells and I would put them in a petri dish, grow them up, and they would fill up the bottom of the dish. We call that confluent. 1 cell thick, all right, 1 cell deep, and they'd stop dividing. Now, here again, when they got to be 1 cell deep, they detected that that was enough division, and they stopped dividing. Now we know now some of the some of the enzymes and all that are involved in, and the genes that are involved in some of this stuff. But that was another example of how they detected that they were confluent. Now, what I could do is I could take that confluent culture of cells and I could put them in 10 more dishes and they'd start dividing again. So now all of a sudden they detected that they were not full. They was not crowded out in a dish, and they'd start dividing. They'd continue dividing, fill up the bottom of the dish until they're confluent, and they would stop dividing again. And I could do that 3, 4, 5 times. And then something else happened. The cells wouldn't divide anymore. I could split them in a lot of different dishes and they wouldn't divide anymore. They were now senescent. Something had happened to these cells. They weren't dead. They were a little overweight, and they would crawl around the bottom of the dish. They weren't dead, and they would not divide. So, what had happened? The cells grew old. They senesced. Does this mean they didn't have the signals anymore? Were the signals not there for them to divide? I don't know. I did the same experiment with cancer cells, lots of different cancer cells, and I could split them 1 to 10 and they'd fill up the bottom of the dish. But you know what? They wouldn't stop dividing. When they filled up the bottom of the dish, they wouldn't stop dividing. And they piled up on top of each other until the ones on the bottom starved and died. That was a completely different response. Human cancer cells, human normal cells became senescent. Human cancer cells would not stop dividing. One of them lost the signal to divide. The other lost the signal to stop dividing. So you wonder what redox signaling molecules are all about, right? So you start looking at the whole body, and two of your experts here in looking at the whole body, or else a piece of the whole body. And really, these bodies are just chemical, electrical, mechanical machines. That's really all they are. It's a little more complicated than that, I give you that, but basically it boils down to chemical, electrical, chemical machines. Now I take that back down from the system level to the organs level to the tissue cell to the cell level. And the cells, guess what? They're electrical, chemical, mechanical machines. Now most of the mechanical part is electrochemical. That's beside the point. Most cells don't have bones, right? But it's still a machine. I love these things. Most people think these cells are just a bag of salt water, and it is, but it isn't. I look at a cell more like downtown Hong Kong before the virus hit. It's very busy. Lots of different, thousands of activities going on in those cells. And you know what? You have on average 75 trillion of these cells with all those thousands of activities going on at the same time. Wow. And what's making them happen? Redox. You know what redox is? Reductants, oxidants. If I come over to you and take away an electron, I just oxidized you and I was reduced. If you take an electron away from me, I was oxidized and you were reduced. And that's what makes the world go round. The sun shines, give energies to the plant. By redox, they create carbohydrates, which we ingest and use to make energy. It's all electrons coming from me, going to you, and vice versa. I love the way this thing works. I told you I'm simple-minded, right? And it's just all about electrons. It's that simple. It's redox. Now, wait a minute. It says something else. It says redox, cell, and I told you about the cell, but it says signaling. Now, where does the signaling come in? Where does the signaling come in? This time of year, we're all familiar with football, right? Everybody lines up, the umpire blows a whistle, and they go, right? NASCAR, we have 50 cars lined up. Somebody waves a flag and they take off. Boom. You go to the Olympics, somebody shoots a gun and they start running. But you know what? It always starts with a signal. There has to be a signal. The umpire doesn't walk up to the football line and say, you guys can start playing anytime you want to. The flag guy doesn't walk up to the NASCAR people and say, hey, anytime you guys want to take off, take off. Olympics don't stand there with their gun stuck in their holster and say, hey, you want to run? Run. I don't care. No, there has to be a signal. It has to be organized. If it's downtown Hong Kong, folks, It has to be organized, which means there has to be a signal, and it's got to start. Guess what? All of these thousands of activities that are going on in the cell, they have to start. They don't start without a signal. And I saw it when I saw that sea urchin egg change colors. You want to know why I'm excited about this stuff? I'm sorry.
This is awesome.
But I really love cells. And now that I've learned about redox signaling molecules and my ping pong game has improved, then I'm even more excited.
You know, Ralph, I've one observation I could make, because when I first learned about this from a physician, one of the things I did what you did, because he wouldn't tell me. He just said, go Google it. And he said, your wife needs to get on this stuff because she had so many problems. And it was like, why can't you just tell me? And he said, just go Google it. You'll find it. And so I did, and I got into PubMed, and I went down that rabbit hole. And it was delightful, because it started, like you, it started answering questions. But one of the biggest questions I had is, how come I didn't know this already? Where have I been? I mean, I think I'm a pretty smart guy within my field, but I had not heard of this. And it's like, and all of a sudden things started to make sense. Does that square with what you're trying to say?
Oh, it's exactly where I was. I had never heard of this stuff. Okay. Even though somebody got a Nobel Prize a few years before I retired, I had still never heard of this stuff. I was working on a cell division, and I told all my students, hey, the answer is going to be in kinases, folks. You got to start looking at these kinases. There's these tyrosine kinases. All of these kinases are going to be what makes things happen. And I was right, but there's something that happened before that.
Right.
They had to be signaled. And we throw out words like signaling. I hope you can see why I think signaling is important. But there's another word that I want to throw out here that people just kind of go over every once in a while, and the word is foundational. It starts it, folks. Nothing happens unless it starts. Nothing starts unless it's signaled to start. Nothing happens by itself. Football isn't a bunch of random, highly padded people running around on the football team. That's not the name of the game, okay? Although I've heard some people from other countries think that's really what it's all about, but that's another story, okay?
You know, Dr. Ralph, I love this. I love the way you're explaining it, because it's really kind of the missing link, right? You know, I talk about it as being kind of the secret communication or the secret language of the cells, because we always knew that, say, if you cut yourself, that you turn on a cascade and all sorts of things happen. You know, you stop bleeding, fibroblasts come in, the tissues heal. But it's that signaling that we never talked about. It's that step or that switch that is flicked that causes everything to go into action, really. So it's really fascinating. But this is going on in every cell of our body. And like you were saying, and Dr. Lee was saying, when I was first exposed to this 8 years ago, I'd never heard that verbiage either.
Right.
It wasn't until I looked into the science that I realized that exactly what you were saying. We were talking about reductants and oxidants, and kind of going back to the Krebs cycle and the energy production and all. But if you could, because this happens all throughout our body, in every cell of our body, why is it important? Why did you feel that change? Why do we all feel that change when we get on the product? What is it doing? And explain why some people don't feel a change, and does that matter? If you don't mind taking a moment to address that.
The feelings, I think it's really cool if you got the feelings. I didn't have the feeling, okay? Somebody else had my aha moment. But you know what? I've been drinking Asea for 7 years, and there's things that are still happening to me, okay? You were very kind by saying that I don't really look 80 years old, and you're right. I'm only 79 and 8.5 months. But things are continuing to happen. And I heard of a guy in North Carolina at one of our Asea meetings say something I have latched onto, and I just absolutely love it. I am going to die young at a very old age. Okay. And this is important to me. Why do we need to supplement our body's own supply of redox signaling molecules? Remember the normal cells I said that grew about 50 divisions and became senescent? Why? Did they run out of molecules? That's one of the things that happen. And we know as we get older, probably starting about puberty, that our mitochondria are making probably 10% less per decade. And my puberty was a few years ago. So you can see I've been through a few iterations of these 10% per decades. So if my body is not making as many of these redox signaling molecules, which are necessary to start all of the processes in all of the cells, by the way, cells in different parts of the body are making different things. I mean, there's different processes going on in my liver cell that's not going on in my brain cell. Well, brain cell, that's a story for another day. Let's say a digestive system, whatever. But these processes have got to be started. If I'm running out of the start products, okay, if my gun is running out of bullets, okay, if my flag is dripping on my flagpole, if my whistle is lost its whistle, and I can't start these processes, I'm going to have problems. And my cells, because my cells have problems. So in order to keep them as healthy as possible, I would like to supplement these cells' supply of redox signaling molecules. Now, when I was a kid, I could run around all day, climb trees, fall out of trees, trip over rocks, skin my knees, sleep like a log all night, get up, do it all the next day. I'm having trouble doing that right now. Actually, I'm playing pickleball about 4 or 5 hours a week, and it surprises me that my body is continuing to be in one piece. I can get sore there for a few hours, and then all of a sudden, I'm not sore anymore. And I go like, thank you, redox signaling molecules. I feel, yeah, when we play the next time, I'm ready to go again. When I'm not playing pickleball, I'm jogging. I used to run. You know, I had some medical problems here over the last year or so, which you heard last time when I was on here. And so I got to where I was walking 2.5, 3.5 miles a day. And that got to be boring. So I started jogging. So now I'm jogging. Now I'm playing pickleball. Now I'm jogging, you know, try to keep my energy up and try to keep my muscle tone good. So all of that because I don't bounce like I did when I was a kid. So I need to supplement my body's own supply of redox signaling molecules. And that's all I'm doing.
Okay. I've got something I want you guys to address. Lee, you brought it up, and I want to make sure because you guys were all medical. I'm not. But Lee, when you say I just Googled it, there may be some things out there that kind of say this is just silly saltwater. Okay? And Ralph, can you address that real quick? Because I know there's a lot of new people. They're not all medical because the bottle does say that it's made from salt water. Can you please address that so people don't think they're being schnookered by buying salt water from Salt Lake City?
Well, people are going to believe what they want to believe. Okay. And if you want to believe everything that you read on Google, then when you go to the bathroom, read the back of the door, because I'm sure that's just as true. But a couple of places you can go. I'm sorry, Dr. Marie. Shame on me.
Hilarious.
The old school days.
But Google Scholar is a great place to go. Okay. If you want to Google it, go to Google Scholar. All right. I go there occasionally because that has more information, and it doesn't go into the weeds as much as PubMed.gov. All right. So that's if you want to Google it, go to Google Scholar. That's a good place to go. All right. You can even see some of my papers on Google Scholar, by the way.
Fantastic. Dr. Ralph, let me ask you a question, because I was just thinking about this as you were talking about it and the senescence of the cells. Do you think that if we're on this product, can we keep the cells from going into senescence, or delay that? Do you think there's a benefit to getting on this product earlier in life? Or can you speak to that? Like, what causes the cells to become senescent?
Well, I don't know what you mean by earlier in life. One of the things that we look at is stress, because we know stress affects the balance of reductants and oxidants, which needs to be balanced, because if the oxidants start taking over, you start getting all kinds of diseases and problems. So they need to be balanced, and you need enough of them. I was talking about enough, okay? Things that can reduce the level of redox signaling molecules, or at a younger age, get the oxidants and reductants out of balance with each other, is stress. I've been talking about my stress, which is 80 years old. I consider aging a stress, okay? Trust me, it is. You'll get there someday. But there's lots of other stresses. There's nutritional stress, okay? And I'm very pleased to be on here with Ms. Ann, because she knows so much about something that I know very little about. But I do know how important the nutrition is, okay? And if you don't get the proper nutrition in this day and age with processed foods and stuff like this, it's good. It's a good probability that you're not going to get all of the proper nutrition that you need, and you're going to have to supplement that. But there's environmental stress, okay? You can play pickleball 5 hours a week, and you're going to have muscle stress, all right? There's all kinds of stresses that you can have. And there's mental stress. I've done experiments on this. Would you want to hear one of my experiments with mental stress? I took medical students who were studying for their boards and medical students who weren't studying for their boards. And we had, they were run through a battery of psychological testing to see what their level of stress was. And I measured the ability of their lymphocytes to repair damage. And the medical students that were under stress, the ones that were under, and this is mental stress, okay? This is a mental stress, it's not a physical stress. The ones that were under a stress, their lymphocytes, which is very important for your health as far as your immune system is concerned, did not repair the DNA as well as the ones that were not under the stress. I got lots of interesting experiments. I also did one, by the way, with people who were meditators and people who were not meditating. So now you could say, okay, well, the stress is going to be a lot less for those who meditate, right? So what is the ability of their lymphocytes then to repair DNA? Was it the same? No, it was not the same. The lymphocytes from those people who were meditating repaired the DNA much slower. Yeah, that's exactly that. Yeah, that's what I said when I saw that. I go, what the heck is going on? But the level of repair was higher. It went above 100%.
Wow.
In other words, because they were actually repairing slower, they caught more damage and was able to repair it to an even greater level than those who were not meditating. I love cells, all right? You go. And these are all hints, all right? Now we're looking at stress. Now we're looking at de-stress, all right? I did these experiments with chronological age people, starting with very young kids. At the time, I had very young kids, so we got some of their lymphocytes. And we went into nursing homes and other areas where people were not sick, but were now staying, well, nursing homes, that's not the one I want. Retirement villages.
communities.
Okay.
Yeah.
And we got lymphocytes from people all the way from 14 years of age all the way up into their 90s. And we found out with chronological age, the ability of their lymphocytes to repair decreased with chronological age. Not surprising. Remember, I said we're making 10% less of the redox signaling molecules per decade, probably starting at puberty. So when we got these results, I was not surprised. But you know, it wasn't until I started looking, I heard the redox signaling molecules, and I started looking at this research that I could start explaining some of these results that I had found with medical students, with people who meditate, and the chronological age. So now I can start explaining all of this in terms of redox signaling molecules. And I love it. Okay, this is great.
So, Dr. Ralph, how big of a discovery, accidental discovery, is this? How, I mean, based on your education, your experience, how big is this?
Well, you're talking, you want to know how big it is, you've got to go back to that word, which is glossed over, in my opinion, much, much, too much. And that word is foundational. All right, it is foundational.
Mhm.
It is foundational to all the activities that are going on in my liver cell. It is foundational to all the activities that's going on in my skin cells. It is foundational to all of my cells. So how big is it? Take the foundation away and you can answer that question yourself. There is no way to actually describe how important it is, because nothing else happens without the foundation, the signal to start all of these activities. I love these things. You like numbers? Okay, you look, the encyclopedia for all of these activities and all of these molecules is in the DNA of the nucleus of most every cell in the body, right? The encyclopedia. The DNA doesn't do anything. It just kind of lays there and says, use me. But the encyclopedia for all of that information is right there in the nucleus of every cell. You know, if you took all of that DNA and you put it end to end, how long it would be? 2 meters, over 2 yards from one cell.
Wow.
Now you have on average 75 trillion cells. So if you took all of the DNA from all of the cells and you put it end to end, how long would that be?
Long.
Twice the diameter of the solar system.
Wow.
Crazy.
Oh my God.
Now look at your hand and wiggle your fingers and say, nice job, guys.
Mhm.
This machine is a little more complicated, okay?
It's amazing.
It was created and it is complicated, but guess what? It works.
It's amazing.
It is truly amazing.
So cool. You know, Dr. Ralph, I know you're probably not doing experiments anymore, but it would be so cool if you could do an experiment looking at the lymphocytes of people on Asea relative to those who are not on it, you know.
Yeah, absolutely.
Yeah, just to say, and I can figure out probably what the results would be just based on what we know from how people, you know, it counteracts oxidative stress and stress in general. But, you know, before when I was saying that, this company is only 10 years old. So most of us have only, I think there's one gentleman who was on the product previously, Marlon.
Yeah,
Marlon Toombs.
Yeah, he's been on it for quite some time. But for the majority of us, we've been on it for 10 years or less. And when I was saying that before about, younger people, you said you don't bounce anymore. I'm just wondering your opinion. If somebody is younger and gets on this product and has been on it for a long period of time, will they be bouncing into their later years? I mean, just looking at this group here and knowing, the ages of the people on this call, I think we all look and act and behave younger than our stated ages. And it's been pretty amazing to see that, even you, Dr. Ralph, at 79 3/4, how good you look. Dr. Lee looks like he's dropped 5 years, in just the past year or so. Jim and Ann look very youthful. It's amazing.
Well, you have too, you know that,
So
right?
do you.
Well,
And you're the youngest acting one here, Maureen.
What about Karen Riley? You see her just about every week, right?
Yeah.
crazy.
I mean, my goodness, how young has she gotten?
It's awesome. Who
It is. It is.
The aging.
But it's due to the cells. Okay, it's your cells. All right. When they skin cells, epidermis cells start getting older, they lose these molecules. They lose the ability to act like they did when they were much younger. And all you're bumping up some of the redox molecules that they no longer have. You just supplemented it, so they act like they're younger. You're talking about, and I love saying this. Stevens and Associates did the experiments where they found out that by putting Renew 28 on the skin, the cells actually turn over, about 16% faster?
Yeah.
In a short period of time.
And so the word is, okay, then the skin looks younger. No, I agree. I say no. It is younger. It doesn't just look younger. It is younger than it would have been had you not put the Renew 28 on the skin. Now, is this anti-aging? No, it's not anti. You didn't go back. All right. I'm not going to be 60 years old again, but the skin is younger. And the dermis underneath, okay, the fibroblasts, which I love, is making more collagen, more elastin, all of these neat stuff.
Right.
So the appearance then is highly improved, no question about it. But the epidermis, those stem cells in the epidermis turning over 16% faster, that epidermis is younger than it would have been had you not put Renew 28 on it.
That's an intriguing point. One thing I'd like to have you comment on too is you talked about the DNA just a moment ago,
Okay.
and its significance. And in the last 10 years, all we hear about is DNA, it seems. But kind of the new kid on the block is the idea of epigenetics. It's the influence, the overlay on the DNA that tells the DNA what to do. And I think that goes back to the signaling part, which is one of the secret ingredients, the missing link that, Dr. Maureen was talking about. Could you explain, perhaps in just as lay terms as you can, the mitochondria's role in creating those signaling molecules that does influence the DNA and make it do different things?
Yes, absolutely. There by the way, the mitochondria has its own DNA. That's why a while ago I was stressing nuclear DNA. Mitochondrial has its own DNA. It isn't as extensive, and the repair mechanisms in the mitochondria for its DNA are not as healthy as the repair enzymes in the nuclear. But what happens in the mitochondria, the process I had talked earlier about, the sun making energy, and in the mitochondria taking the carbohydrates to create energy for the cells, that is done in the mitochondria. There's a process in there which all medical students love and have to memorize called the Krebs cycle. Also, see Dr. Maureen. It's also called the citric acid cycle. And after that happens, there's another part to it called electron chain transport. And as molecules are processed through the citric acid cycle and the electron chain cycle, electron transport, these redox signaling molecules are produced. And that's where they are produced. Now, what happens with stress is that the mitochondria do not divide as well as they used to. So when a cell divides, mitochondria have to divide. So you have the same number of mitochondria in each cell, right? But if they're not as capable of dividing, then you're going to end up with some cells who don't have as many mitochondria. So reduction in mitochondria means reduction in the number of redox signaling molecules that are made. That's one of the problems. The other problem is that the DNA in the mitochondria can be damaged. So the mitochondria itself is not as efficient in the Krebs cycle as it was without the DNA being damaged. So it is not capable of making as much of the redox signaling molecules as it did before it was damaged. So there's two things that can go wrong. Actually, both have to do with DNA damage. One of them is the efficiency of producing redox signaling molecules. The other is efficiency being mitogenesis for the mitochondria to actually divide.
I know the biggest
Is that
stressor.
what you wanted?
Yes.
Okay.
Could you speak to the fact that I know age is the biggest stressor on mitochondria, but what other things cause stress to the mitochondria?
Specifically, you probably should be asking Miss Ann about that one. All right? Because she knows the nutrition, all right? And nutrition is going to be critical. Obviously, if the oxidants get out of balance with the reductants, okay, the oxidants in the mitochondria are going to start doing the damage to the mitochondria membranes. And the membranes of mitochondria, by the way, are critical to the operation of the mitochondria. But also the start oxidizing and mutating the DNA, so it's not as efficient. So it all has to do with nutrition. All right, you need the proper nutrition. You need the materials, and mitochondria needs the materials from the rest of the cell.
What's pretty amazing is our company being a total cellular health company, because here we have the redox, and then later came Renew 28, which gives us more redox through the skin, working head to toe, and then you marry that with our Via line, which gives you all the micronutrients, enzymes, all the things your body's lacking from this horrible Western diet that many people have. But the Via line is synergetically working with redox, which is going to then give your body the best results. And if people would study oxidative stress and mitochondrial dysfunction and intracellular repair, they would realize that without redox, nothing else really is going to work. And so as we age, we need to be doing more redox. People are, if they're doing the same amount of Asea 10 years ago, they need to up it, because you're not going to stop oxidative stress. It's all around us. It's going to keep happening. So arm your body with the best defense. So maybe you want to address some of that. Lee had a comment. If you want to make your comment, Lee, or any one of y'all address what we're talking about.
Go ahead with that. And our friend Dan asked a question about the relationship of some of the Me Too products out there that claim to be NRF2 activators, and more specifically in his question, the alkaline water. There's just kind of a dearth of understanding out there about that.
Ralph, did you?
But Ann, yeah.
No, that was to you.
Okay, well, there's a lot of good products out there, okay?
Right.
And quite a few, by good products, I mean, they work, all right? And I think that's awesome. But remember what I said the word that I think is the most important, and that is foundational. Okay. None of these other products are going to work without the redox signaling molecules, because redox signaling molecules are foundational. So yes, there's a lot of products out there that are good products and they work, okay, but they are not foundational. And what Asea has is a foundational cell redox supplement, all right? So the other products will probably work better if you're drinking Asea. That's all I can say. And by the way, did you like the way I set you up there, Miss Ann, with your nutritional? I thought I did that quite professionally.
Great segue. Hey, if you don't mind, we need another disclaimer. We're being asked about it treating stuff. You guys, this is not a medical product. It is a supplement. So it's not meant to treat or cure any particular disease or challenge. What it does do, as Dr. Ralph is explaining, is help. It's foundational to your cells doing their job. There's innate wisdom in your body, in your cells, so that they know what they're supposed to do. So when you give it the proper tools, we see all sorts of amazing things happen. So we can't make any claims along those lines, but when your body is working the way it's meant to, miraculous things can happen. I'll leave it at that.
Let me append that with this thought, and that is connect the dots. You know, when Dr. Ralph and Dr. Maureen and I hit Google Scholar early on, what we were doing was looking at the basic science, and we were looking at what is redox signaling. And if the cell is working well, and any specific disease is the consequence of cells not working well, and we can get the cells to work well, that foundational thing, then you can kind of reach your own conclusion as to what might happen. And that also explains a little bit of this idea of, well, why doesn't it work? We have this mindset, especially in today's allopathic medicine, pharmacologic medicine, herbal medicine mindset, that when I consume something, I need to feel it. I need to have an effect. Something has to start or stop or be different that I can measure quantitatively or qualitatively. And at the foundational level, it's not something that you can always measure and have a distinct, change or difference occur. And that's why I really appreciate Dr. Ralph's comments about the foundational stuff, because I think that's the answer as to why not everybody has a 48-hour turnaround in their health or with a specific problem, is it takes time. It takes time to rework that epigenetic and DNA foundation and to reverse all those years of bad things happening at the cellular and even subcellular level. So that's my 2 cents worth on that.
And, you were talking about foundational. You can only live 3 minutes without redox signaling. I mean, you can live on without eating for 3 weeks. So, I mean, think about how important it is to have your bank of redox signaling, until they deplete. And it's obviously a very looked at science. If you look at Google Scholar having thousands and thousands, and then you look at PubMed, type in redox signaling, you'll see thousands. And then you look up JAMA, another one for medical professionals. There's so many studies out there. I mean, people just need to listen and try it. 90 days, 90% see a change in 90 days.
And that's why we're here. We're getting close to the bottom. We've interviewed John Norton, who is one of the founders' sons. And I was talking to him. We did this show a number of years ago. And he says, Jim, I have so much fear over what we have. And the responsibility that we all have that are right here, right now, in setting correct expectations, in trying to that's why these medical people are here. And I can't tell you how much I appreciate Maureen and Lee and Dr. Ralph and the time that it takes for us to do this, because we care. Because if people get the wrong idea, and if we don't set correct expectations, somebody could get on it for a week or 2 or 3 or a month or 2 and go, it isn't working. Dr. Ralph, is there ever a time, besides maybe when you're dead, where these molecules can't work? on everything alive, plants, animals, and humans. Is there ever a time where they cannot work?
I think they do work when you're dead.
Have you tried it? Have you tried it?
Not personally. That decomposition, it's kind of a gross thing.
Oh, that's all. Oh, Maureen.
I'm gonna let Dr. Ralph take over.
Now let's erase that section when you're decomposing. Good God.
Yeah, okay. I can't see her now. That's good. I covered her.
Okay. The
answer to your question is no, okay? But that's a simplistic answer, all right? As long as you have cells, all right? As long as you have cells, it cannot not work. It will work 100% of the time on all of your cells.
Mm-hmm.
So as long as you have cells, it will work. Now, if your cells don't need more redox signaling molecules, it'll just go back to salt water. All right, and it'll be recycled. But it cannot not work. It will work 100% of the time on 100% of the people. Absolutely.
Yeah.
And because it is native, that's a word I haven't heard today.
I was just going to say it.
Native, because it is native, Pepper Black said, it can't hurt you.
Yeah, non-toxic.
That's right. It cannot hurt you because it's a native product. And that's why, as long as you have cells, all right, redox signaling supplement is going to work. It'll make your cells healthy. Now, when I drink, I drink, I don't know, 10 to 16 ounces a day, no less than 10. But you know what? Every time I drink Asea, I don't feel my liver feeling better.
Yeah.
Thank you.
My skin doesn't say, oh, I'm so glad you drank that Asea. Even sometimes when I put Renew 28 on it, my skin doesn't say, oh, that feels so good. Unless my knees are hurting and I put it on my knee, by the way, and then my knee says, oh, thank you for that. By the way, do you know why Asea, why these redox signaling molecules can make pain go away? Do you know why that happens?
Well, one of the pathways.
It's a cellular thing.
Mm-hmm.
All right. Mm-hmm. And it's really quite simple. Remember, this cell biologist is a simple guy. What is pain? Okay, pain is something pushing on a nerve and the nerve is saying, ouch. It's just that simple. Pain, ouch. All right, so what's pushing on that nerve? The chances are something has swelled up in that area and that swelling is pushing on that nerve and that nerve is saying, ouch. And what is causing that to swell up? Some sort of inflammation. All right, some sort of irritation. So you put redox signaling molecules in that area, and Stevens and Associates showed that the microvascular circulation is increased 40% within 20 minutes. I mean, right away. So that swelling goes down, and guess what? That swelling's not pushing on that nerve anymore, and that nerve's not saying, ouch. It is really that simple, folks. This is complicated. I don't have to go back to my tyrosine kinases anymore.
No.
Are you saying it's foundational to everything in the human body?
I wished I had said that, Glenn.
I take full credit.
That is so perceptive of you.
What can I say?
I'm going to write that down right now. Okay.
Hey guys,
Glenn says.
Hey guys, we're at the top.
We're going to have to continue this.
Yeah, right. Ralph, this time goes way too fast when we have you on this show. I'm serious. I can't thank you enough. What we have is so overwhelming.
It is.
It is such a gift. And we're here because we want people to understand the importance of this. We're doing this because we don't want people to walk away and say it's just a silly dietary supplement from saltwater from Salt Lake City and its network marketing, which we haven't even talked about. But thank God it is, or you know what? We wouldn't be here.
That's right.
We wouldn't know about it.
We wouldn't have a clue. And the most illegal pyramid, as far as I'm concerned, is American corporations. What we have is the most freeing, American way of doing business, worldwide people doing business and having no cap on your income. And we've been given a gift. So Dr. Ralph, thank you. Guys, next week we have Dr. Carmen Keith. She is a triple boarded doctor from Harvard. We've had her on before. Honestly, her story will just get people to come on the call. Yep. And right now there is another call coming on live with Danny Doyle and Stevie, where they're from Australia. They sound a little bit different, but guys, listen to what they have to say. This is going to continue right here, right now. So Dr. Ralph, we love you. Pepper Black, thank you so much for talking and getting Dr. Ralph, who is adored and loved at everybody at this company, as is Maureen Hayes, our princess, and our resident expert doctor, Dr. Lee Osler. Guys,
Dr. Maureen and Dr. Lee, I enjoyed being with you.
And
You too, and especially you, and Jim's okay too.
Bye, everybody.
Guys, thank you so much.
Next week, have a great one.
Yes.
Thank you,
Thanks
guys.
again. Good night.
Bye.
Bye-bye.